When you think of a volcano, you're probably picturing a huge explosive eruption, right? A massive ash cloud, maybe some rivers of lava. But some of the most dangerous volcanic activity out there happens way more slowly, through the quiet, steady growth of something called a lava dome. And what they are is just fascinatingly deceptive.
And that brings us to the central puzzle we're going to unpack. These domes can build up for months, sometimes even years, and they look almost calm, but they're hiding the potential to unleash absolute catastrophe in just a matter of moments. How on earth is that possible?
So, first things first, what exactly is a volcanic dome? Well, it's basically this big, steep-sided mound that forms when lava is just too thick and sticky to flow very far. Instead of spreading out across the landscape, it just piles up right over the vent it came from. And this, right here, is the key thing to remember. They are a true geological paradox. They are the ultimate slow burn threat, a silent giant that can awaken with unbelievable violence. So, what's the secret ingredient? What makes a volcano decide to build a dome instead of, erupting in a more familiar way? Well, let's take a look at the recipe. The main difference really comes down to one thing: silica. Think about the runny, honey-like lava you might see in Hawaii. That stuff is low in silica, so gas can bubble out of it super easily. But dome-forming magma, it's the complete opposite. It's packed with silica, which makes it incredibly thick and sticky. Think more like toothpaste. And here's the crucial part. Because it's so sticky, it traps gas. That toothpaste analogy is honestly perfect. Imagine squeezing the tube. The magma is just too viscous, too stiff to flow away. So it just oozes out and piles right up on itself, getting bigger and steeper with every single push from down below. Okay, so let's just walk through how this whole thing happens. First, you've got that gassy, sticky magma rising up. As it gets closer to the surface, the pressure drops and all those gases start trying to escape. But they can't. They get trapped inside the thick magma. This bubbly, pressurized mix then starts piling up. The outside cools and hardens into a brittle crust, while the whole thing just keeps swelling from the inside, a process that can go on for days, months, or even many, many years. So this whole process of trapping gas and growing slowly creates this incredibly unstable situation. What you end up with is essentially a massive geological pressure cooker just waiting to blow. Inside that dome, there is a constant battle raging. You've got trapped gases pushing outwards with tremendous force. You've got the molten interior pushing relentlessly up from below, and get this, as the magma cools a bit, crystals start to form, which makes the leftover liquid magma even stickier, ramping up the pressure even more. And all of that is being held in by a brittle outer shell that's constantly cracking under all that strain. Now, when that internal pressure gets to be too much, the dome has to release it somehow. Often, it starts by shedding its outer layers. And these aren't just simple rock falls. We're talking about glowing avalanches of superheated rock and gas called block and ash flows that just scream down the sides of the volcano. And those smaller avalanches? They are a massive warning sign. They tell us the dome is getting unstable. And if that instability keeps growing, the entire structure can fail. And that is when the real catastrophe begins. A full-on collapse triggers this horrifying chain reaction. You get pyroclastic flows, these superheated clouds of gas and ash moving at hurricane speeds. You get even bigger block and ash flows that incinerate absolutely everything. And sometimes, that sudden release of pressure causes a massive explosion, as all those trapped gases expand violently all at once. And look, this isn't just some abstract theoretical danger. In 1902, the world witnessed the terrifying power of a collapsing dome firsthand.
On the island of Martinique, the lava dome on Mount Pelée collapsed. It unleashed a pyroclastic flow that completely obliterated the city of St. Pierre, killing almost 30,000 people in just minutes. It was a horrific, tragic lesson in just how devastating these things can be.
So this is that paradox in action. You can have years of slow, almost unnoticeable growth. Then, for maybe a few months, you start to see some signs of instability. But the final, destructive part of the story, that happens in minutes. The change in pace is just staggering. So, given this incredible danger, how do we protect people? Well, thankfully, scientists have developed some really sophisticated ways of reading the warning signs. Today's volcanologists have this amazing toolkit. They use things like GPS and tilt meters to measure the ground swelling, down to mere millimeters. They use thermal cameras to spot new hotspots on the dome's surface.
They can even smell the volcano's breath, analyzing its gases for clues about what new magma is doing deep inside. And all the while, seismic sensors are acting like a giant stethoscope, listening to every single crack and rumble of magma on the move.
And all of this data, when you put it together, gives scientists a much clearer picture of the dome's stability. Now, they can't predict the exact second of a collapse, but they can forecast periods of much higher risk. And that gives authorities precious time to issue warnings and, if necessary, get people out of harm's way.
But as destructive as these domes can be, it's really important to remember that they are also part of a much larger constructive process. They are one of the Earth's great reshaping forces.
This really shows you the two sides of the coin. For every destructive force, like a pyroclastic flow or plugging event that could lead to a bigger explosion, there's a constructive one. Over long periods, these exact same processes are building new land, they're sculpting incredible landscapes, and they're creating unbelievably fertile soil.
In fact, when you zoom way out over geologic time, that same sticky, silica-rich magma is a key ingredient in building the actual continents we live on. Repeated dome-building events slowly but surely add new material to the crust, literally helping our landmasses grow. So the next time you see a picture of a volcanic dome, remember, it's so much more than just a pile of rock. It's a window into the deep, fiery engine of our planet. It's a slow, tense, powerful expression of a world that is constantly changing, building, and reshaping itself from the inside out.